dependency inversion principle, the D in the solid principles of object-oriented design. The dependency inversion principle is one of the most important principles of building object-oriented software, and we're actually going to have to split this module into two parts because there's quite a lot to cover. We're going to start off by defining the dependency inversion principle. We'll outline some of the issues that occur in software that does not follow this principle. We'll further demonstrate that with an example in which we'll see how these problems arise. And then we'll analyze that problem, figure out a way to refactor it in order to apply this principle. And then we'll have a look at some related fundamentals that apply as well along the way. So the dependency inversion principle states that high-level modules should not depend on low-level modules. Both should depend on abstractions. Furthermore, abstractions should not depend on details, but rather details should depend on abstractions. This is from the Agile Principles, Patterns, and Practices in C# book by Robert C. Martin and Micah Martin. So, if you've been following along on these modules thus far, you know that I like these motivational posters that demonstrate these principles. This one is for the dependency inversion principle and says, when you solder a lamp directly to the electrical wiring in a wall, as you can see with our electric gadgets, we have a common interface, which is our plug, which if you're in the US looks like the one shown in the upper right here. And using this common interface, we're able to plug in any number of different devices that implement that interface. That's what dependency inversion allows us to do as well. When we write our classes in such a way that their dependencies are exposed as interfaces, we are then able to pass in implementations of those interfaces just as we're able to plug in any particular device we want into the wall socket. So before we go any further talking about dependency inversion, we should consider what exactly are dependencies. Obviously, if you're writing .NET software, you have taken a dependency on the .NET platform, the .NET framework. It's more or less on Windows unless you're developing for Mono. And this is something that is not, within the scope of dependency inversion per se. It's a dependency that you're probably pretty comfortable with and that you don't expect to change too much with the course of your software. However, the dependencies we're talking about with regard to our application design are more low level and things that we are going to expect to possibly change as part of our application during its lifetime. For example, access to third-party libraries. These can often be things that will change frequently, and therefore, if possible, we want to be able to inject alternate implementations of these third-party libraries into our code. Thus, we're certain that our choice of third-party libraries is not likely to change for the lifetime of our application. Certainly our database represents a dependency, assuming that our application has one, and it's definitely one of the things that you will want to wrap in such a way that it is not an implicit dependency within your code, but rather something that could be injected and replaced. We'll see more about how to do that soon. Other dependencies are less obvious. For example, if your code references the file system, if it uses email, if it sends email or even checks email from a pop mailbox, for example, if it uses web services or really any kind of network access at all would be a dependency as well. Any sort of system resources, even things like just the clock that you might access via datetime.now represent further dependencies that might require you to invert in the case of situations where they affect the behavior of your application and there's no way for you to test it unless you run it at certain times of day. Configuration can be a dependency in terms of the files that you use for configuring your application. The new keyword is itself a possible indication you've got a dependency within your application. You want to limit places in which you allow your application to instantiate new objects, unless they're primitives like strings, for example. And related to that is the use of static methods. Anytime you're calling a static method, you're adding a dependency to your code that cannot easily be separated from the calling code in the case of trying to run a test for it, or in the case of wanting to change your code, the way your code works throughout the entire application in one place. if you have static methods sprinkled throughout your code, it's very difficult to change them all through one configuration change or one startup file change. Thread sleep can also be a dependency, as well as use of random. And it can be very difficult to test code that is supposed to give you random results. So if you specify an interface that you use for generating your random values, then in your test you can override that interface and say, well, if the random value is this, then I actually expect this result. And similarly, it allows you to more easily test so-called random data. These are some of the dependencies that you should be aware of. It's certainly not an exhaustive list, but I think I've covered most of the major ones that you'll typically find in a .NET business application. Most traditional programming works in such a way that dependencies naturally accrue within the code because the higher level modules tend to call lower level modules, and by calling them, they also tend to instantiate them as they need them. So it's very typical for you to have, for instance, a user interface application that references some business logic, and it might use one of those business logic classes, perhaps a customer class or an order class, and do some work with it. And in the course of calling the methods in that class, maybe it has to talk to the database, or maybe it has to talk to some other sort of infrastructure. Typically that business logic class would then new up a data access component or a logger component or some other kind of class to do its work. And so ultimately, the user interface is depending on the business logic depending on the infrastructure and utility and the data access classes. Furthermore, it's often the case that the facade layer is implemented using static methods in order to facilitate a simpler API for those business level methods. It's much simpler for the business logic method to be able to call save customer on a data access layer static method than for it to implement 20 lines of ADO.NET code itself. So these can also represent dependencies that can be very tricky to extract out of your application. And finally, it's typical that class instantiation and call stack logic is scattered throughout the application. This violates the single responsibility principle because now every class that is deciding who its collaborators are through the use of static methods or the new keyword to instantiate specific instances with which it wants to work is now responsible not just for its actual work, but also for determining who it's working with. And these are actually separate responsibilities that single responsibility principle should dictate that you want to put into separate classes. When we're talking about class dependencies, we want to be honest. That means that our class constructor should require any dependencies that that class actually needs. Classes whose constructors make this very clear have what we call explicit dependencies. However, classes that do not make this clear have implicit or hidden dependencies. They're lying to you when they say that you can just new them up without passing them anything, but then they don't work if the database isn't there. That's telling you something that is false. It's telling you that this class would work, but then it's not letting you know about the fact that, oh, by the way, I actually need a database in order to do anything. So for example, here's a class called Hello World Hidden that has a hidden dependency on the system clock. And so it'll work a certain way in the morning, and another way in the afternoon, and another way in the evening. But there's no way for you to alter that dependency. In this case, it's violating the open-closed principle in that if you wanted to change logic for the dates or the times of day when it does its thing, or if you want to be able to test it in some way that lets you run all three paths through the method without having to run your tests at different times of day, you would have a hard time doing so. So your classes should instead declare what it is that they need. For instance, with the Hello World example, we need a date time in order for us to determine which greeting to pass back. We could pass in a date time through the constructor, or if we wanted to and it was only being used for one method, we could pass it into the method itself. If we don't want to pass in a particular value object, like a date time, we could pass in an interface that knows how to return date times, such as an iCalendar that perhaps implements the now method. And then we could write an implementation of the iCalendar interface that used the system.datetime.now implementation by default, but then when we were writing our tests, we could use whatever implementation of that we wanted, and we could have an afternoon iCalendar that always returned 2 p.m., for example, and we could use that in our test to verify that we received good afternoon whenever we passed in the afternoon calendar implementation. Let's look at a simple demo showing how violating the dependency inversion principle can cause problems in your application. In this example, we're going to look at a simple e-commerce application which includes an order class that represents customer's order. And the order class has a checkout method which takes in a shopping cart. The shopping cart has some items in it that the user is purchasing. We have some payment details that will have values such as credit card or cash. And we have an option for whether or not we want to notify the customer when their order has checked out. If we look at the logic for this, we can see that when we have a credit card payment type, we're going to charge the card. In any event, we're going to reserve some inventory. And if the customer has requested it, we will notify the customer. As it stands here, we see that there are no explicit dependencies being set in the constructor for the order class, nor are there any implicit dependencies in this method that would be shown with a static method call or a new instance of a particular implementation. However, when we start to drill down into these methods that it's calling, for instance, notify customer, you can see that we do in fact have dependencies on mail message and SMTP client, datetime.now, which is a static method, as well as a logger static method for this error method here that they're using for error handling. Similarly, the inventory reservation method uses an inventory system that it instantiates, and charge card likewise use a new payment gateway. So the dependencies in this class include the payment gateway, the inventory system, the SMTP client and mail message classes, the logger, as well as datetime.now. We'll be able to find a lot of these dependencies using the architecture generate dependency graph by class menu item in Visual Studio 2010, assuming that you have the correct version. And if you do that, you'll get something that looks similar to this, which will show you all the class level dependencies and will show you the static methods. So you'll see here that we're depending on payment details, cart, logger, order item, etc. The only static method it's not showing is the datetime.now. Our logger method is in fact shown here. In fact, it's not going to show you anything that's in the framework. It's only going to show you classes that are defined within your project with the settings that I've used. So what's the problem here? The issue is that if we want to try and test the order class, it's going to be difficult to inject some of these classes that it requires. If we look at our test class, we have 2 tests written so far. We named our class order checkout should, and it lets us use sort of a sentence structure when we say these tests. We say order checkout should not fail with no items, no notification, and no credit card. So we set it up with a new order, a new cart, payment details of cash, and we set the notify customer to false. When we run this, we don't have any real indication of success or failure except for the fact that we assume that if we didn't get an exception, it must have worked because our method is a void method. And so we can run this one test, and it does in fact pass when we have nothing to do and no items to do it with. The next one is that we don't want it to fail when we have no items, but we do have notification, and we still have no credit card. So at this point, we've set a customer email to this bogus someone@nowhere.com, and we specified should notify customer to true. When we run this test, however, we get an exception because I'm running this on my developer machine and I don't actually have an SMTP server running. So if we view this test results, we'll see that it was a system.net web exception, unable to connect to the remote server, and it was unable to make a connection to port 25 of localhost.